raised to a power of a variable. Something like x squared or x to the fifth, those are not exponential functions because the x is the base. When the x is the little number that's up there, or a y is a little number, or a z is a little number that's up in the air, that's called an exponential function. The b value that that exponent is attached to is called the base. In this case, a and b are both going to be constants, and we want to check and see what the a and the b do to the function. So, on number 1, our a value is 3, and our b value is 2. Everybody okay so far? All right. So I'm going to plug 3 times 2 to the x in my calculator. So I just put in 3 times 2 to the x power, and I'm going to go to my table. Alright, how is this table changing? How am I going from 3 to 6 to 12 to 24? What are they doing? Yeah, it doubles, or it multiplies by 2. So let's see what happens if, on problem number 2, we switch our a and our b values. So now a is going to be 2, and b is going to be 3. Do you think that's going to change anything? Yeah, probably. All right, so this time as we're moving down the table from 2 to 6 and 6 to 18, this time we're multiplying by 3. Remember, the b is the base. So on number 3, what is your b value? 6, because that's what the exponent is attached to. Well, if the b value is 6, what is the a value? 1. Remember, most of the time in math, if something is understood, it's a 1. Remember, if we have an x by itself, we understand there's a 1 in front of it. If we have a number with no exponent, we understand that the exponent is a 1. Same thing here. Our a value is understood to be 1. All right, so I'm going to put 6 to the x power in the calculator. This time, I go from 1 to 6, 6 to 36, multiplying by 6. On 4, our a value is 8, and our b value is 0.5. Okay, so this time as I'm moving down the table, 8 to 4 to 2 to 1, what are you multiplying by? 0.5. Okay, so without plugging it in the calculator, can you tell me what your a and your b value are and fill in the table for this next one? Without plugging it in? All right, our a value is 100. B value is 0.5. So 100, 50, 25, 12.5, 6.25. ratio you multiply by. All right, is everybody good so far? Pretty easy. Okay, so on the next page, first at the top, the A.
Wait, can you go back for a second?
Sure.
Did you fill out the top one?
Mhm. All right. A is what we call the initial value. And just like we said on the front, it's where x equals 0. Now the reason it's called the initial value is because most of the time when we use exponentials, it's to do word problems. And the initial value is going to be something like the initial amount of money, or the initial value of your car, or the initial number of people in a city, or the initial amount of bacteria, or the initial amount of radiation, or it's always the initial amount of something. That's why we call it the initial value. B is the ratio. All right, it's the ratio by which the y values change. Now, they don't always increase. Sometimes they decrease. So if you look back at the ones on the page before, what caused the y values to increase and what causes them to decrease?
Whole numbers or numbers greater than 1.
Numbers greater than 1. When b is greater than 1, it causes them to increase. When b is between 0 and 1, it decreases. So when it's a fraction or a decimal that's less than 1. Now, we'll talk in just a minute about negatives. None of the ones we did were negative. We'll talk about that in just a minute. All right. So let's look at the table. This time we don't have a function to put in our calculator. We need to look at our table and see if by our table we can determine what our A and our B are. So what is your A value on number 7?
5.
And what's your B value?
4.
All right, so this is going to be 5 and 4, and it's changing by 4. Well, that's easy enough.
Yeah.
Y'all don't forget how easy this is, okay? So in a few days, when I give you a problem like this, don't go, where am I supposed to get the A value? What's A on number 8?
2.
Good. And
4,
B?
9.
That's crazy. All these people out there must know these lessons.
I mean, it's kind of a good thing.
Yeah, if we didn't miss anything, this is a good thing to miss.
Not like
All right, what's your A value?
16.
16. Okay, so now this one's a little bit different because my B value, it's obviously going up, so my B value is greater than 1, but it's not,
1.5.
yeah, it's going to be a fraction or decimal greater than 1 because 2 times 16 would already be 32, and it's not quite that much. So if you're not sure what it is 1.5, but if you weren't sure, moving down the table we're multiplying, which means moving back up the table we're dividing. So if you're not sure, you could always take 2 of your y values, move up the table and divide. So I could do 81 divided by 54. Or I could do 36 divided by 24. And it tells you what your ratio is. What's your A value on number 10? 500. This time it is definitely going down, which means my number has to be a fraction or a decimal. Everybody good? Okay, last 2 things on this page. 4 to the 1, 4 times 1 to the x. If I plug that in my calculator,
It
function, you can't have a base of 1 because 1 to any power is 1. So it doesn't matter what we plug in there, it's going to come out to be 1 and then multiplied by the initial value. So 1 doesn't work as an exponential base. And then if you do the same thing with the negative value,
It switches. It oscillates because negative and positive.
right? Yep. True. All right, so if you plug this in, it goes back and forth from a negative to a positive to a negative to a positive to a negative. So, and if you try to graph that, it won't graph. Because even if we weren't doing, right now we're doing integers, but the same thing would happen if we did decimals. It would go back and forth and back and forth and back and forth and back and forth. It's called oscillating. It would go like this. And that is not an exponential function. So your base can't be negative. Now, your a value can be a negative, but your base cannot. So the thing that your exponent is attached to, it will not be negative, even though sometimes your a value might be. All right, is everybody good so far?
Wow.
Okay.